Okay, so in today's lesson, we're going to be talking about geological effects caused by gravity. All right. The objective by the end of this, I want you to be able to explain how the gravity from other objects creates geological activity on other objects. Now, those other objects, what I mean by that is how can one planet's gravity cause geological effects on another planet? Okay, and what I'd like you to be able to talk about by the end of this, or the terms I'd like you to know, is geological activity, geyser, and magma and lava. All right. I just want to tell you what geological activity means. It means the movement of the planet, activity that causes changes on the planet. So examples that are geysers, volcanic eruptions, earthquakes, that's geological activity. Okay, so what we're going to be talking about is how that geological activity can actually be caused by one planet's gravity interacting with another object's gravity. All right, so the first things first is a geyser. Let me move my face for you so you can actually see what's going on. So here we go. We have a geyser spraying water up. All right. So a geyser is water that erupts out of the earth, usually created by heat from the earth. So this is an eruption of water just shooting into the air, and it shoots meters into the air. It gets quite high. It's quite impressive, and it's usually created by heat in the earth. So what happens is in the earth there's this cavity, and that cavity fills with water. And let me actually show you a picture. So over here's a picture of a geyser, or a cartoon of a geyser. If the geyser has this area where water is stored, and the heat from the bottom of the earth causes that water to heat up, and the water begins to boil. And what happens is the water boils and starts foaming up, but then it travels through a narrow opening which sort of shoots it up into the air. Okay, so a geyser is basically just water that's shot out of the earth high into the air. It's like a volcanic eruption except with water. All right, and it's created because inside this chamber, inside the planet, pressure builds up and that shoots it out of a small opening in the water. Okay, so that's what a geyser is. That's the first thing you need to know. Now we're going to actually talk about how geysers are created by gravity. So let me move my face again. Okay, so we're going to talk about Europa. Europa is one of the many, many, many moons of Jupiter, and it is surrounded by ice. It's surrounded by ice. All right, so Europa actually has geysers that shoot water 200 kilometers high. So just to give you that idea that when a geyser erupts in Europa, it actually shoots water high enough for that water to end up in space. Okay, and the way they're created is not by heat but by gravity. Okay, so there's no heat on Europa, it's frozen, but there's liquid water under the ice, like in Antarctica. There's liquid water under the ice of Europa. Okay, and the huge amounts of gravity created by Jupiter. Remember, Jupiter is one of the biggest planets, has the most mass. So if it has huge amounts of mass, it has huge amounts of gravity. So as Europa moves around Europa moves around Jupiter, Jupiter is pulling with all its might on Europa. And so it's pulling on that water under Europa, and it's creating this water sloshing around on Europa. And what happens is when that water is pushing hard enough against the ice on the outer layer of Europa, the water finds a weak point in the surface or an opening in the surface, and it's shot out of that opening. Okay, so same way with the geyser on Earth, heat creates pressure inside the planet. Heat creates pressure inside the bottom of the geyser, and that shoots it up. The pressure is created on Europa by ocean waters that are being pulled by Jupiter's gravity, and they're pulled so hard that when they find a small opening, they shoot out. They shoot out with huge amounts of force. All right, so that's the first one. Geysers created on Europa by Jupiter's gravity. The second one I want to talk to you about is volcanic eruptions. You all know how volcanic eruptions work. Before we move ahead, I want to talk about magma and lava. Magma is what we call lava when it's underground, and when it erupts out the top, it's called lava. So magma, I'll talk about magma when it's underground. When it gets out onto the surface, it's called lava. All right, so volcanic eruptions take place when there's an opening in the surface of the earth. Okay, so whenever there's an opening that cuts through the crust and goes straight down to the mantle, okay, then a volcano can erupt if magma basically is pushed through by magma flows. Okay, so magma flows upwards through that opening and becomes lava. That's how volcanic eruptions happen. And then the reason they're pushed out is just because of the way the Earth is moving. There are these things called convection currents, and they're just naturally being pushed out slowly. It might seem incredibly fast to us, but it's actually quite slow. All right, now I want to tell you about Io. Io is another moon of Jupiter. And in fact, Io is the most volcanic object in the solar system. It's more volcanic than Earth. It's more volcanic than Venus. It's quite amazing, okay? So Io is the most volcanically active planet in the solar system. It's not a planet, it's a moon, though. Okay? Io's volcanic eruptions are created by the gravity and not by magma flow. So what happens is, because Io is so close to Jupiter, it has this gravity pulling on it. And it also has two other moons, Europa, which we spoke about, and Ganymede behind it. So what's happening is Io is in the middle, being pulled by Jupiter, and being pulled by Ganymede, and being pulled by Europa in all these different directions. And the crust around around Io is busy being squished and pulled in all these directions. And what that causes is cracks in the surface, and it squishes them out. And when it squishes Io down, magma shoots up at the top and covers the surface, creating these volcanoes. And as Io moves around, the pull of Jupiter and Ganymede and Europa in all directions. And it's constantly being squished and pulled, and that is causing volcanic eruptions the entire time on Io. Okay? Oh, I don't know what that is. All right. The lava coming out of Io has such force that it can shoot 10 kilometers high. So if you're standing on Io, it would shoot 10 kilometers into the air. Imagine a spout of lava going that high. To me, that blows my mind. Anyway, boys, that's everything. Hopefully you can do everything. If you can't, come ask me a question. Have a fantastic day. Bye.